Looking at the calendar, it's January 2026.
Oh.
And it feels like no matter where you go, a coffee shop, a boardroom,
Oh, anywhere.
there is one topic you absolutely cannot escape.
The shots.
The shots, exactly. Ozempic, Wegovy, Mounjaro, Zepbound. I mean, for the last 3 years, the entire culture has been obsessed.
It's completely obsessed.
Yeah.
But the conversation is always about the same things.
Right. It's pretty shallow. It's celebrity shrinking or the stock market
Right.
or the diet culture wars.
Right. It's almost always framed as the end of obesity or, the ultimate lifestyle hack.
Exactly. But I've been going through the stack of research you brought today, and stack is, putting it mildly, it's a mountain. And I think we need to completely reframe this. Because if I'm reading this right, we are not just looking at weight loss drugs. We might be looking at the first proven longevity medicines ever.
It sounds like hyperbole, doesn't it?
It really does.
It sounds like, marketing spin. But when you look at the hard data, especially this massive new study from late 2025, and you combine it with some fundamental genetics work from the 90s, it starts to look like the weight loss is actually the least interesting thing they do.
And that is the mission for this deep dive. We're going to connect the dots between a study of 500,000 people, the biology of tiny, tiny worms, and really the future of how we all age.
It's a fascinating puzzle.
Yeah.
So let's get into it.
Okay, so let's start with the immediate context. For a while now, we've had this Battle of the Titans narrative going on.
Right.
In one corner, you've got Semaglutide, that's Ozempic and Wegovy. And in the other, the newer, supposedly stronger challenger, Tirzepatide.
Mounjaro and Zepbound. And the whole assumption has been that Tirzepatide is the, quote, better drug.
Why? Just
Right.
because it leads to more weight loss?
Pretty much. In the pure weight loss trials, it just posted higher numbers. It hits 2 hormone receptors instead of 1, so, the logic was more receptors equals more power.
But we never had a fair fight on the thing that actually matters most.
Heart disease.
Cardiovascular outcomes. We just had separate trials, different people, different rules. We never had a direct head-to-head.
Until now. And that's this Kruger study, published in Nature Medicine just a few months ago, November 2025.
And this wasn't some small experiment.
No, this was a massive undertaking.
So let's talk about how they did this, because the method is actually really clever. They didn't run a traditional trial, did they?
No, a traditional randomized controlled trial would take, 5 years? $1 billion. They used something called target trial emulation.
Okay, so break that down for us. Why does that matter?
Well, usually when you look at real-world data, like insurance claims, it's a total mess.
Right.
Sick people take different drugs than healthy people. Doctors prescribe things for different reasons. If you just compare them straight up, you get garbage results.
Because there are too many variables. You don't know if the drug worked or if the patient was just healthier to begin with.
Exactly. So what target trial emulation does is it uses these sophisticated statistics to take that huge, messy data set
And clean it up.
and force it to follow the strict rules of a clinical trial. You basically create a virtual clinical trial from historical data.
That's brilliant.
It is. They took data from U.S. insurance databases from 2018 to 2025. Over 450,000 people starting semaglutide, 136,000 on tirzepatide. And they matched them perfectly.
Same age, same health history, same risks.
It's as close to a coin flip experiment as you can get without actually flipping a coin.
And the big question they wanted to answer wasn't who loses more weight. It was who stops having heart attacks.
They looked at myocardial infarction, heart attack, stroke, and all-cause mortality, the heavy hitters.
So, cut to the chase. Who won?
Well, if you were betting on a knockout, you'd lost your money.
No way.
It's statistically a draw.
A draw. Really? But tirzepatide causes more weight loss.
Yes. And that's what's so fascinating. When they compared them directly, the hazard ratio was 1.06. In plain English, that means there was no statistically significant difference between the two for major heart events.
That is genuinely surprising, because if weight loss is the main reason for the health benefits, shouldn't the stronger weight loss drug protect the heart more?
That's the logical assumption.
Right.
And we did see a tiny hint of that in one area, heart failure.
Okay.
Tirzepatide had a very slight, non-significant edge there. And the researchers think it's because heart failure is often a mechanical issue.
Like the load on the pump.
Exactly.
Yeah.
Less body weight means less physical stress on the heart muscle. It's just physics.
That makes sense. But on the flip side.
On the flip side, semaglutide had a tiny numeric edge on MAE, major adverse cardiovascular events,
Yeah.
which is mostly about arteries, clogging up and bursting.
So tirzepatide might be a little better for the heart muscle, semaglutide a little better for the arteries.
Possibly.
Yeah.
But honestly, we are splitting hairs. The real takeaway from this study isn't about which one to take. It's that both of them are profoundly effective compared to the older drugs.
Right.
We aren't just shrinking waistlines. We are actually stopping the #1 killer of the developed world.
Which brings us to the next layer of this. Because if both drugs protect the heart pretty much equally, but the weight loss is different, that implies the protection isn't just about the weight. Something else is going on.
Exactly. And this is where we need to bring in Lotte Bjerre-Knudsen.
She's the chief scientific advisor at Novo Nordisk, right? She's basically one of the mothers of this whole class of drugs.
That's her. And she gave a presentation recently where she did not mince words. You know how scientists usually hedge their bets?
Oh, yeah. Potential benefit. Promising signal.
She stood up and said straight out, Semaglutide is a proven longevity medicine.
Wow. That is planting a flag. Proven longevity medicine.
It's a huge claim. And she backs it up by showing that these drugs are doing systemic repair work that has nothing to do with calories. She talks about inducing homeostasis in the inflammatory system.
Okay, the word inflammation gets thrown around so much. What does she actually mean by that?
She means that chronic, low-grade systemic inflammation, the kind that smolders in your body for decades.
That's the engine of aging, basically.
It drives everything. Atherosclerosis, Alzheimer's, kidney failure, and Knudsen presented data showing these GLP-1 drugs just dampen it across the entire body.
And that connects to the plaque stability thing you mentioned, right? Because that part fascinated me.
Yes. A heart attack usually happens when a plaque in your artery, which is like a little pocket of cholesterol and angry cells, becomes unstable and bursts.
And the clot that forms is what blocks the blood flow.
Boom, heart attack. But these drugs, they seem to change the composition of the plaque itself. They make the cap over it thicker, they calm down the cells inside it, they make it stable.
So even if the plaque is still there, it's just less likely to kill you.
Far less likely. It's incredible.
And it's not just the heart. I was reading the section on the liver in her presentation, and that distinction she made between fat and scars, that really stood out.
This is the smoking gun for the independent of weight loss argument.
Okay, lay it out.
So with metabolic liver disease, first you get steatosis, that's a fatty liver. Then the inflammation causes fibrosis, which is scarring.
And that leads to cirrhosis and liver failure.
Exactly. Now, what Knudsen showed was that while the drop in liver fat correlates perfectly with weight loss,
Makes sense.
the improvement in liver scarring does not.
Wait, say that again? Two people could lose the exact same amount of weight, but the person on the drug sees their actual liver scar tissue heal, and the person just dieting might not.
Precisely. The drug is signaling the liver cells directly to repair that fibrotic tissue. It's actively healing the organ.
So it's not just removing the insult of the fat, it's applying a salve to the wound.
That is organ protection. That's longevity medicine. You see it in the kidney, the heart, the liver.
Okay, but why? It seems too good to be true. Why would one hormone that tells your brain to stop eating also tell your heart to fix plaque and your liver to heal scars?
That is the billion-dollar question.
And to answer it, we have to go back in time. We need to talk about the 1990s and worms.
The humble roundworm, C. elegans.
We have a transcript here from a lecture by Cynthia Kenyon, a geneticist who basically broke the whole paradigm of aging.
She did. Before Kenyon, science mostly thought aging was just, entropy. You're like an old car.
Things wear out.
Parts wear out, things rust, it just falls apart. No program, just physics.
But Kenyon looked at nature and said that doesn't make any sense. A mouse lives 2 years. A bat, which is basically the same size, can live for 50.
Right. If it was just parts wearing out, they should degrade at the same rate. So she suspected there was a dial, a gene controlling the rate of aging. And she found it in these worms, a gene called DF2.
And when she mutated it, when she turned it down, what happened?
The worms lived twice as long.
Twice as long. And I watched the clip from her lecture. It's not like they were just comatose for an extra month.
No, that's the crucial part. She shows a video of normal worms at 2 weeks old. They're sluggish, barely moving. She calls it their nursing home state. Then she shows the DF2 mutant worms at the exact same age. And they're thrashing around, energetic, youthful. She said it's like meeting a 90-year-old human who looks and acts 45.
That is mind-blowing. Okay, so what is DF2? What does it do?
This is the aha moment. This is the connection. DF2 is the receptor for insulin and IGF-1.
Insulin, the blood sugar hormone.
The very same.
Yeah.
In evolutionary terms, insulin and IGF-1 are the signals for feast.
Abundance.
Abundance. Food is everywhere. So these hormones spike, they bind to the receptor, and they tell the body, grow, reproduce, build tissue, store energy.
Pedal to the metal.
Exactly. But running the engine at redline all the time creates damage. It accelerates aging.
So when you mutate DF2, or when you lower those insulin signals, what happens then?
The body goes, oh, wait, resources might be scarce. We can't grow right now. So it flips a switch. It activates a different gene called DAF16. Kenyon calls it Sweet 16.
And what does Sweet 16 do?
It's the general contractor for home renovation. It shifts the body from growth mode to maintenance mode.
Okay.
It turns on genes that repair DNA, clear out junk proteins, fight oxidative stress, all the good stuff.
So it's a binary choice. Grow and age fast, or repair and endure. And insulin is the toggle switch.
Yes, and this isn't just worms. It's conserved across nature. Flies, mice, even dogs. Small dogs live longer than Great Danes, mostly because they have lower levels of IGF-1.
But wait, I have to play devil's advocate here.
Go for it.
We're talking about GLP-1 drugs. Don't they stimulate insulin release? That's how they lower blood sugar? It sounds like a contradiction.
It does seem like a paradox, but you have to look at the long game. Yes, right after a meal, they help the pancreas release insulin efficiently. But the key is they also fix insulin resistance.
The broken law.
Right. If you're insulin resistant, your body is just screaming at your pancreas all day, pumping out massive amounts of insulin just to get the job done.
So you're basically marinating in high insulin. You're stuck in aging mode.
Exactly. By fixing the sensitivity and by helping you eat less, these drugs drastically lower the overall circulating burden of insulin and IGF-1 throughout the day.
So by fixing the whole metabolic system, we are effectively turning down that feast signal.
We are turning down the volume on DF2. We are pharmacologically tricking our bodies into entering maintenance mode, just like Kenyon's worms.
That is just incredible. We take a drug to fit into a suit, but on a cellular level, we are telling our genes to act young again.
It explains why the benefits are so widespread. If switched the entire system to repair mode, every organ benefits.
Which leads us to the final frontier, the one organ we haven't really touched on yet, the brain.
The most important one.
We have a source here from Daniel Drucker, another giant in this field. He points out that GLP-1 receptors are inside our brains and not just where you'd expect for appetite.
Right. And Lottie Knudsen mentioned this too. Novo Nordisk is running huge trials right now. Thousands of patients looking at semaglutide for Alzheimer's.
And the thinking there is, what, inflammation again?
It's a big part of it. We know Alzheimer's involves neuroinflammation. So if these drugs can cross the blood-brain barrier and calm that down, just like in the heart, maybe they can slow the disease.
We don't have those results yet, but we do have data on something else in the brain that kind of surprised everyone.
Surprise guess.
Addiction.
Yeah.
Drucker mentions these real-world reports of reduced alcohol use, fewer opioid overdoses, even people just quitting smoking without trying.
I've seen this anecdotally everywhere. People go on Ozempic to lose 20 pounds, and then one day they realize they haven't wanted their nightly glass of wine in weeks,
Yeah.
and they didn't even try to stop.
They just didn't want it.
The desire was just gone. It seems to lower the volume on the craving signal in the dopamine reward system.
But this raises a kind of philosophical question, doesn't it? Someone actually asked Knudsen this. They asked, if we dampen the reward system, do we kill the joy of life?
The zombie fear.
Right. If I stop craving wine, do I also stop craving art? Do I become a flat, emotionless robot?
It's a valid fear. If you mute the highs, do you mute joy? But Knudsen's answer was really profound. She distinguished between homeostasis and anhedonia.
Anhedonia being the inability to feel pleasure.
Exactly, a feature of severe depression. But patients on these drugs actually report feeling happier. She argues that addiction to sugar, alcohol, whatever, isn't joy. It's noise.
It's a screaming voice in your head.
It's static. And if the drug turns down the static, you can finally hear the music. You have the freedom to choose your actions instead of being driven by this relentless dopamine loop.
So it's not removing desire, it's removing the desperation of desire.
That's a perfect way to put it. You can still enjoy a piece of cake. You aren't held hostage by it anymore.
So let's zoom out. We started this deep dive talking about weight loss shots.
A very 2023 way of looking at it, yeah.
But what we've really uncovered here is something so much bigger. We have a molecule that protects the heart, lowers inflammation everywhere, heals liver scarring, protects kidneys.
It quiets the demons of addiction.
And it does all this Probably because it flips an ancient genetic switch, conserved from worms all the way to us, that shifts our entire biology from aging mode to repair mode.
It's a whole new category of medicine. We call them anti-obesity drugs because that's what we see in the mirror, but biologically.
Biologically, they're systemic repair drugs.
Like so.
It just makes you wonder about the future. Right now, you have to be pretty sick to get these. You need a high BMI or diabetes or heart disease. But if laudanum is right, if this is truly proven longevity medicine,
Should we all be taking it?
that is the ethical and economic question of our time, isn't it?
It is. Cynthia Kenyon asked 30 years ago if we could find the fountain of youth by tweaking our internal dials. It really looks like we found the dial. Now society has to figure out who gets to turn it.
And here's a final thought for you to chew on. We spend so much energy obsessing over the number on a scale. But if a drug can protect your heart, clear your liver, save your kidneys, and give you back control of your own brain, is the fact that it makes you skinny actually the least interesting thing about it?
I think the science is screaming yes.
Thanks for diving deep with us.
Stay curious.